All right, welcome to Organic Chemistry Nomenclature Day 2. And in Day 2, we need to learn about naming branched hydrocarbons. So the assignment from last week was about how to name the simple hydrocarbons, which were the alkanes, and the alkynes. So the alkanes, as you may recall, all had a single bond. The alkenes had double bonds, and the alkynes had triple bonds. And so as we go forward and when I start doing things, I'm usually going to use the number of bonds as the underline, the type of the suffix that helps visualize stuff. So just wanted to show you that little trick. Now, there's a lot written on this slide, but basically naming an organic structure is just a process. So when I was in college, I was under the impression that I just had to memorize all the structures. So like I made flashcards, and I had a flashcard pile that was almost 6 inches tall, and I had like 2 or 3 of them because I was trying to memorize everything, and that was a terrible idea. What I should have done is spent time memorizing processes. So the process that you want to follow is to identify if a structure has straight or branched is a straight or branched structure. And in this case, I see that it's branched because I have a number of carbons that go 1, 2, 3, 4, 5, 6 straight across, and then I have, or 5 straight across, but then I also have one that kind of comes down, and so it looks like it's branched. So in this instance, this is a branched hydrocarbon because there's something coming off of a chain. So now we number the continuous chain of carbons. So I'm going to go ahead and highlight what I think was the continuous chain of carbons. So my first one would be 1, 2, 3, 4, 5. Okay, so that's 5 carbons long. And just to check, I'm going to check the other option, which would be 1, 2, 3, 4, 5. Also 5 carbons long. And just to check, I'm going to check the other way, 1, 2, 3, 4, 5. So any way that I do this, this is going to be a 5 carbon long chain. So I'm going to highlight the easiest, most obvious chain, and this is the straight chain. The chain doesn't always have to be straight though, but sometimes it makes your life easier if it is. So then the next thing I'm going to do is I'm going to count the carbons closest to a multiple bond. And in this chain there are no multiple bonds. So the next thing I'm going to do is I'm going to count the number of carbons in the longest continuous chain and number closest to so that the branch is the first thing. So I'm going to circle this and I'm going to call it a branch because that's really what it is. But I'm going to number as close to the branch as I can. So that would look like this: 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. And in this case, it actually doesn't matter which side I number from because I still get to the branch on the third carbon either way. Because I'm right-handed and because I read left to right, that's how I'm going to number this chain. It actually doesn't matter. You can number it the other way if you feel like it, but that's fine. So the next thing I'm going to do is I'm going to name the chain as if it were an alkane, an alkene, or an alkyne. And because this has a single bond, all single bonds in the parent chain, it's going to be an alkane. So I'm going to write the suffix ANE. I'm going to put a line under it to remind me what it is. I'm then going to go ahead and I'm going to name the number of carbons in the continuous chain. And because there's 5 of them, I know that the prefix for 5 is pent. So it's a pentane. And now so that part of the chain is taken care of. Now I want to go ahead and identify the number of carbons that are on the branch. So the branch is the thing that's coming off of the chain. So in this case, I've got 1, 2 carbons long in my branch. And so that tells me that if I was going to add a prefix to it, it would be the prefix eth. And I would add to that YL. Now, when you add a YL to a name or a part of a name, that signifies in organic chemistry that you have a branch and not a chain. So this is going to actually be an ethyl. Let's do it like this. So this is an ethyl pentane. And then the last thing that we have to do is we have to go ahead and identify where the ethyl pentane is. And so the ethyl branch is on the third carbon, so we're going to simply put a 3 and a dash, and we're going to call it 3-ethyl pentane. So that's all that's to it at its most basic. It does get a little bit more complicated. There are some other things down here that we didn't touch, and we'll talk about those in other examples as we go forward. So here's another example. This one looks a little bit more complicated. So the first thing we need to do is identify if the structure is straight or branched. And I see a lot of things going on here, so the first thing I'm going to do is find the longest continuous chain, and I definitely see that there's branches. So I'm going to highlight and go one, oop, that's not the right thing I wanted to do. I'm going to highlight and go 1, 2, 3, 4, 5, 6, so that would be 6 carbons long, or 1, 2, 3, 4, that would be 4 carbons long. 1, 2, 3, 4, 5 would be 5 carbons long, and also 1, 2, 3, 4, 5 would be 5 carbon. 1, 2, 3, 4, 5. Wait, hold on. What did I do here? 1, 2, 3, 4, 5, 6 carbons long. I screwed that up. So then the other option would also be 1, 2, 3, 4, 5, 6, also 6. But now this other option is 1, 2, 3, 4, 5, 6, 7. So my longest continuous chain isn't straight, and it happens to be 7 carbons long. Okay, so I'm going to talk about numbering in a second, but what the next thing I'm going to do is I'm going to identify my branches. So here I have one branch. Oops, that's not what I wanted to do. So here I have a branch, another branch, another branch, another, oh, that's not a branch, got carried away, and another branch. Now I'm going to number my chain. I'm going to number it closest to the first branch. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons, or 1, 2, 3, 4, 5, 6, 7, 8. So this is an 8 carbon long chain, which is important because I said 7, and I can't count apparently. But now I'm going to identify when I get to my branches first. So if I go from left to right, I get to my first branch on the 4th carbon. If I go from right to left, I get to my first branch on the 3rd carbon. So this time I have to number from right to left. So I'm going to erase all this business here because we don't need it. And okay, so now this is my chain that I'm going to number. So the first thing I'm going to do is I'm going to identify the type of chain, and I only see single bonds, so that's going to be an alkane, so it's going to end with ane. I see that it's 8 carbons long, so I'm going to call it the prefix for 8, which is oct. Okay, so it's an octane, and then the next thing I'm going to do is I'm going to figure out my branch situation. So I see that I have 4 total branches, and of the 4 total branches, I have a 1 carbon long branch, 1, 1, and 1, and I have a 2 carbon long branch, 1 and 2. So I'm going to name my branches, and all branches end their name with YL, right? So YL, 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 and YL. And then the next thing I'm going to do is I'm going to add the appropriate prefix. So in this case, this is going to be a methyl, a methyl, a methyl, okay, because it's all 1 carbon long, and 1 carbon means meth. And then this is going to be an ethyl. So an ethyl. So I have ethyls and I have methyl branches. So now what I'm going to do is, in order to put them in the right order, I have to alphabetize my branches. And when I do the alphabetizing, I know that E comes before M. So I know that my ethyl has to be one of my first things. So this is going to be an eth, YL. And then I have 3 methyls, but they're not in the same spot. So I'm going to write, so because I have identical branches, I'm going to combine them by adding the prefix tri. So it's going to be something like methyl. Oh, I should write more clearly because I'm going to clean this up anyway. Methyl, but before that I'm going to write tri. And then, oh man, I need more room. So I've got that part. All right, so let's clean this up a little bit. So I know that the ethyl appears, and this is going to be sort of important here, the ethyl appears on the 5th carbon. I have a methyl that appears on the 5th carbon, the 3rd carbon, and the 3rd carbon. So to clean this up and finish this properly, I'm going to start by naming. So I'm going to write 5-ethyl, if I can use letters. Geez, that's a T. 5-ethyl. And then I'm going to have to identify the place of all of the methyls. So there's a methyl on the third carbon, a methyl on the third carbon, and a methyl on the fifth carbon. So I'm going to have to write 3,3,5 methyl. And then I'm just going to simply add octane to it, like that. So this would be my final answer. 5-ethyl 3,3,5. Oh, I forgot something. Darn it. See, this is how I make mistakes when I sometimes go a little bit fast. I've got to add how many methyls there are, and this is where redundancy comes into place, and it's a little bit cumbersome sometimes. It's a trimethyl octane. Now, this is the final answer. Happy I caught it, because that's going to be an important skill set. So I realized that saying 3,3,5 and then trimethyl is a bit redundant, and it actually is a bit redundant. However, in this particular nomenclature system, that's what we have to do. So we not only have to tell the location of the multiple methyls, we also have to tell how many methyls there are, and that's just the way this system works. This like I said, is basically a process, but it's also almost like a recipe, because it tells you exactly what's involved in the actual compound itself or structure itself. So here we have one more example about naming. Identify if the structure is straight or branched. I can see that there's branches coming off, but now the next thing I have to do is find the longest continuous chain of carbons. So I'm going to go, so I'm going to go 1, 2, 3, 4, 5. Okay, that's something. Then I'm going to go 1, 2, 3. Well, then I'm going to go 1, 2, 3, 4, 5, 6. So it looks like in this case I have a 6 carbon long chain. Then it tells me to number the chain. Closest to the multiple bond if there is one. So 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. So if I were numbering this chain, I would have to number from left to right, because I get closest to the multiple bond in the fewest number of steps. So I'm going to erase the other options. Okay. Now, if there were a multiple bond and the multiple bond happened to be a tie, that is, if I counted 1, 2, 3 from the left and 1, 2, 3 from the right, then I would break the tiebreaker by going to the number of the branch that's closest when you count from left to right or right to left. So in this instance, if the double bond was after the third carbon, so if the double bond was like, here, I'm going to draw this real quick so we can see it. 1, 2, 3, 4, 5, 6. So if we had this, so if I numbered this one, and I know I'm taking a little bit of a tangent here, but this is important. So either way I number this chain, I would be at the third carbon, so I can go left to right. So the way that we would break the tie is if there was a branch and we did something like this here, or we did something like this here, right? We would end up numbering from left to right because the branch is closest to the front instead of the other way around. So that's the quote-unquote tiebreaker. So double bonds or multiple bonds are, I like to say, trump branches, but if there's a tie with a multiple bond, then you use branches to figure out the best way. Sorry, that was a bit of an aside. So now I need to go through and actually finish naming the structure. So I see that there's a double bond, and that double bond is tells me that the suffix has to be ENE, because the double bond is right here. So double bond. I see that my chain is 6 carbons long, so that's going to be a hexene. Now, here's where we have to tell the world where the multiple bond is. So we know that the multiple bond is after the second carbon, so it's going to be a 2-hexene, because that's telling me the location of the multiple bond. Okay. Now, after that, I need to deal with my branches. And so in this case, I see that I have a branch here and I have a branch here. And they are 1 carbon long branches. So that tells me that it's going to be, both of them are going to be meth. Both of them are going to be meth. And because they're branches, they get the YL suffix. And because I have 2 of the same type of branches, I'm going to have to use the prefix di. So this is going to be a dimethyl. So I'm going to try to write that appropriately with the right space. So dimethyl. And then I need to tell the world where those methyls are located. So there's one on the second carbon and there's one on the fourth carbon. So this would be a 2,4-dimethyl 2-hexene. Now, the actual structure, or the actual punctuation, commas and hyphens, are important. But as far as I'm concerned, if you're getting the numbers and the words and the prefixes and the suffixes right, that's more important to me than whether you have a comma or you have a hyphen. But really, in reality, we like to separate branches. We like to separate numbers from names of branches and numbers from names of compounds by a hyphen. But if there's more than one number, like in this case, the dimethyl, we would use a comma. Again, sort of minor on my part. Okay, so now we're going to draw structures. I think drawing these structures are a little bit easier than naming them, because we basically can dissect them by working backwards. So, first thing I do is I see that I have an alkene, and I know it's an alkene because there is an ENE ending, and the one here tells me the location of the double bond, which is really pretty important. Then I see that I have a pent, which tells me I have a 5-carbon long chain. So, because I'm drawing this structure, I can do it any way that I want. So I'm going to take 5 carbons. Oops. I'm going to draw 5 carbons. 1, 2, 3, 4, 5. And then I'm going to add all single bonds. And then I'm going to go ahead and add the double bond, and the double bond has to be after the first carbon. So I'm going to number them: carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and because it's my chain, I can number it any way I want. So I'm numbering from left to right. So then I'm going to go ahead and add my double bond, which is going to be right here. So there's my 1 pentene without the hydrogens. Now I need to add a branch, and this time I'm going to add a branch that is a methyl group. So this tells me it's a branch. The meth tells me it is a 5-carbon, or sorry, that's silly. The meth tells me it is a 1-carbon long branch, and the 4 tells me the location of the branch, which would be on the 4th carbon. So 1, 2, 3, 4. I'm going to put a methyl branch here, which is going to have, and I'm going to bond it. Now, the last thing that we have to do is we have to go back and add hydrogens so that every carbon has 4 bonds. So the first carbon, carbon number 1, is participating in 2 bonds because of the double bond, so it only actually needs 2 hydrogens, H2. The second carbon is participating in a double bond on the left side and a single bond on the right side, so it only needs an H. The third carbon only is participating in 2 bonds, so it needs an H2. The fourth carbon is participating in 3 bonds, so it only needs an H. The fifth carbon is participating in 1 bond, so it needs an H3, and the branch definitely needs an H3. So that's your structure. And I like to think that this is easier to draw than it is to name, but I always start with naming first, because sometimes the drawing helps the naming fall into place. So here's another example, which is a little bit more complicated. Hold on as I take a sip of coffee. Okay, so same deal. I'm going to identify the type of structure, which is an alkane. So that tells me that all single bonds. Pent tells me it is a 5-carbon long chain, which is important. I see that there is a YL, and the YL tells me it's a branch, and I see that the meth tells me it's a it's a 1-carbon long branch, and the di tells me that I have 2 branches, and the 2 and the 3 tell me the location of both of those branches. I also see that I have another branch, and it's an ethyl, which tells me it's a 2-carbon long branch. I don't have another prefix, so this tells me it's got to be on the 3rd carbon. So to draw this, I'm going to start by drawing my carbons. 1, 2, 3, 4, 5. 5 carbons. I'm going to add all single bonds. 1, 2, 3, 4 single bonds, because that's what holds them together. I'm then going to number my chain. And because I'm numbering my chain, I can number from left to right if I want to, and I do. 1, 2, 3, 4, 5. Now, I don't have to add any multiple bonds, so I'm going to start adding branches where necessary. So on the 2nd carbon, I'm going to add a singular carbon branch. And make that a single carbon. And on the 3rd carbon, I'm going to add a 2 carbon. So, or I'm going to add let me back this up. Let me deal with one thing at a time. On the 3rd carbon, I'm going to add another methyl branch. And now I'm going to deal with my ethyl. And on my 3rd carbon, I'm going to also add an ethyl branch. An ethyl branch with 2 carbons on it, like so. And now we're going to go back and we're going to add hydrogens so that every carbon is participating in 4 bonds. So carbon number 1 has 1 single bond, so it needs to have 3 hydrogens. Carbon number 2 is in 3 bonds, so it only needs 1 hydrogen. Carbon number 3 already has 4 bonds, so we're good. Carbon number 4 has 2 bonds, so it's going to need 2 hydrogens. And carbon number 5 has 1 bond, so it's going to need 3 hydrogens. Now I'm going to go to the branches. The first branch, the methyl branch, has 1 carbon bond, so it's going to be an H3. The other methyl is going to be an H3. The 2nd carbon on the ethyl is going to be an H2, and the 2nd carbon on the ethyl is going to be an H3. Now, some of you are going to say, does it matter what side you put the branches? Like, could you have put both of the methyl branches down and the 1 ethyl branch up? Does that matter in terms of the location or the orientation rather? And the answer to that question is no, it doesn't matter today. Okay, so one more example and then we're done, and then you'll have a worksheet to do. So here I have, looking at the structure, I have YNE, which tells me it is a butane, which tells me that, it tells me that it is an alkyne. And so the but tells me that it is a 4 carbon long chain, and the 1 tells me the location of the triple bond. So 1, 2, 3, 4 carbons long. I'm going to add my single bonds. I'm going to number my chain. 1, 2, 3, 4. And then I'm going to add my multiple bonds. So in this case, I have, after the first carbon, I have a triple bond. Okay? Now, because I numbered from left to right, because it was closest to the multiple bond, I'm now going to go ahead and add the branches that are coming on here. And so I have, I see that I have a branch, which tells me, the YL tells me it's a branch. The meth tells me it's 1 carbon long. The di tells me that there's 2 of them. And the 3 tells me the exact location. So in this case, I'm going to draw on the 3rd carbon a 1 carbon branch going up and a 1 carbon branch going down, and you really don't have another option here, so this is kind of the way that it's going to be. Now I'm going to go back and add my hydrogens. In carbon number 1, it's participating in a triple bond, so it only needs 1 hydrogen. Carbon number 2 has 4 bonds, so we're good. Carbon number 3 also has 4 bonds, we're good. Carbon number 4 has 1 bond, so we're going to add an H3. One of the methyl branches needs an H3, and the other methyl branch needs an H3. Okay, so that is how we draw basic organic structures with branches and how we name basic organic structures with branches. So your homework is to do the second worksheet, which is drawing branch structures and naming them. It's a two-sider, and if you want to start with the drawing because you find that a little bit easier and then try the naming, that might be a good way to do it. But that will be due on Wednesday, so good luck with that. and we'll have another lecture on Wednesday. Have a good day.